call it H. Is that clear? Too complicated. If you want, you can write a third budget constraint here, but it's pretty silly. It says that what I spend in education is equal to what I borrow. It's just extra symbols. Okay? One can look at that and say, well, let's simplify a bit from the point of view of an investor. The return on investing in H and the return on investing in K is the same thing. Why? Because the only difference would be riskiness, but this is a model with certainty. So as long as there is no riskiness, they're going to earn the same, right? Because it comes out from the same consumption and it pays off in the same consumption. Good, that simplifies a bit the equation. Take away this symbol. Sorry, I made you write it, but I have to. Okay, and we can write like that. Okay. For the rest, it's all very simple. Now, this is a structure that allows the accumulation we said, right? When you're young, basically you decide, is it worth investing in becoming more productive? It's obvious, look at where dt minus 1 is. dt minus 1 is on the left and on the right side of the first resource constraint. Because you say it's going to cost me 1 plus r. How much does it pay off? Well, it pays off tomorrow's wage multiplied how much extra human capital I have, which is what? B. Right? Because per each unit of D, I get an extra B units of human capital. So that's going to be the first order condition, basically. Right? Notice that there is no consumption, right? Because it's all tomorrow. You know, it's you, right? In fact, it's exactly, it's a simple model. It's the simplest model of a student loan, right? Student loan. How should I measure student loan? Why is that convenient? Well, my salary goes up of $2,000 a month. And I have to pay 1 plus R out of that. As long as the $2,000 is larger or equal than the 1 plus R, I can do it. Right? And so the condition actually there becomes very simple because it says that you always have, let me erase this. A simple relationship. The links, you see, sorry, there is T here. The wage, the interest rate and the wage rate are linked, right? Because the third order condition is 1 plus RT equal WT times B, in my simple example. Interestingly, we have other two conditions on that. Because given that RT also pays off in terms of capital stock, the same, no? And must also, it comes from here. How do I choose now saving? I can choose aggregate saving, in fact, and then split it. Aggregate saving simply says that U prime CMT, right? That's my cost of saving, right? If I increase saving, that is this, I lose that. It's equal to delta U prime C old T plus 1 multiplied what? 1 plus R T plus 1. So this is determined by the growth rate of consumption, or determines the growth rate of consumption. Now, let's use Cobb-Douglas so everything is simple, right? WT equal what? A alpha, sorry, 1 minus I. Right? And 1 plus RT equal I don't know why today I'm solving the model, but I feel like get me relaxed. You with me? Now let's take this away. We don't need this constraint anymore. Well, let's use that, no? I write 1 on one side, 1 on the other, I cancel, so what is that I get? I get alpha xt at the alpha minus 1 equal b 1 minus alpha xt at the alpha. Very good. Look at that. Look, cimberi, boom, bim, bam. Oh Dio, buono, subito. Good. This is a very standard property of all these models, by the way. You go right away to the von Neumann array. You see? See the result? How trivial? You go to the steady state capital KH ratio right from the start. It's always there. And it's always determined by the physical parameters. See? It's a very special case. If you read coupons, which you probably unfortunately didn't, but in case you did, this is something he points out. All this model with constant return to scale in every sector, everything reproducible. Right? If you can, you go to the balance growth. And that's the balance growth. That's a ratio. That's it. You're done. Solve the model. The model is solved. Now you have that, you have everything. Right? That determines the growth rate. Now you have to put that into the growth equation, blah, 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 to make sure that it actually grows. right? And interesting, A doesn't matter. It's B that matters. And it actually makes sense. Why? Because A makes both K and H more productive. So it kind of, it affects both in the same way. Instead, B affects only H. And so it becomes relevant. All right, that's it. That's the solution. Just plug it back, gives you everything, the wager, you put it here, and you get the growth rate of consumption. Now you write the two consumption as a function of xt, and that gets you the whole solution. For example, if you use log ut. Obviously, you have to use functional forms. So that's very simple. It's a simple model of overlapping generation with selfish people. You borrow to invest, you pay back the investment, you earn from the investment, you accumulate, make other investments for the future, and that allows future generation to also invest. They borrow from you, and so on. Obviously, if you're generous, nothing changes. You write this model and allow both generosity toward your children and selfishness toward the market. You give something to the children, and you borrow and you lend to others. Makes no difference. Okay? Is that clear? Or not? Now, I have used the model to play a bit with what the model suggests. Right? The model suggests two things that are, so that, first of all, you can make the model more sophisticated. For example, you can certainly make the size of the population not constant. So you can allow for demographic. If you allow for demographic, things change a bit, because say there are a lot of children. Then if there is a lot of children, investing in human capital becomes more expensive. So that tends to favor a higher KH intensity. Because in the production function, the real intensity is K divided HL. So if there is a lot of L for free, why spending resources in H, right? So it suggests that if you have then you can make that L depending on immigration flows, right? Then having a lot of L that comes in makes the incentive to invest in H per capita less strong. You invest more in K and less in H. There's a lot of free L, and you use it. Okay? So what happens in that allows you to see that L, increasing through immigration, actually favors those that own K, because it provides a complementary factor for free. You can play all the games. You can divide L in two types, the skilled and unskilled, right? And see how one favors the other, and so on. And the other thing you can do in a model like this is to say, okay, the market doesn't seem to do that, right? That is, the market doesn't seem to be providing the efficient amount of lending to the young to invest in education. That's my own exercise. What I've done is take this model and use it to think about education and public pension. So remember how the budget constraints work, right? The budget constraints are like this. Basically, when you're middle-aged, you get your consumption. You have, let's put words, pay back student debt, okay? okay? And here you have saving, right? And lending to students, next generation, and here you have income, right? And when you're old, you have consumption, less than return on saving, plus return on lending to student. Okay, that's the structure of that model, right? Right? Okay, let's change the word saving, let's call it financial market, right? Because saving here means buying capital stock, buy share, buy bond, okay? So let's put explicit word, so this is like financial markets saving plus, and this is what? Lending to students, lending to young, that's right, lending to young, right? And here there is return on saving, okay, a return on, you know, payback from young. And so this is actually good because we can write here payback too old. Why am I doing this? Well, because I want to make you think progressively of something that is already here in the world we live in. So that's middle age, and that's old. Okay? So think of the budget constraint of your parents now. Think of the budget constraint of your parents now and start putting in governments and all that. What you get? It's a real question.
Well, if you put in, if you put the government in a pension in the budget constraint of the old.
All right. So the pensions are what? Let's write down the budget constraint of the actual old. The middle-aged Italian and the old Italian. Okay, the middle-aged Italian consumes and then does what? Okay, purchasing finance. What is that it does here? Pay back to old. What is that it does? It pays taxes and social security contribution, both. Well, so we have both, right? So, well, taxes, social security contribution, and financial market saving. Right? That's less or equal than income. Right? And the old has got consumption, less than return on saving, plus pensions. Right? Good. So now if I want to map element into element, what I get? I can start from here, where there is no ambiguity. Right? If I want to map element to element, the thing called pensions here is the payback from the young. In actuality, that's the source. The working people in the middle age are paid for the pension. Right? How are they paying for the pension? The middle-aged are paying for the pension through Social Security contribution. So this corresponds to that. So in the model, what is the payback from the young? In the model, the payback from the young is this, payback to old. So let's think about the model, and we can show that what the model does, if the margins are right, is efficient. The pension have two components. In fact, they're both pensions. Okay? There is a pension that comes from this type of investment,